Assalamualaikum warahmatullahi wabarakatuh. This is Statics Chapter 8, Additional Problem. Right. So the background of this is in the last class, we have finished the class for this semester for statics. But in the last class, some students actually asked me several questions. They asked me a lot of questions. But among the questions, I have responded theoretically what they should consider, etc. But after the class finished, I go back and I relook at the question that they asked. I noticed that in this question, there are some added information that the student need to be able to comprehend for them to be able to draw the free body diagram, for example, and then solve the problem, right? So, and hence in this video we will cover two questions, and hopefully for any question, for any student that do not still understand why the question is being solved in that certain way, hopefully this will help, right? So, for the first question, I'll put it there on this side. Hopefully, I'll be able to put both the diagram and also the question, right? As you can see there, we have the forklift. The weight is given 12 kilonewton, and the center of gravity is also given, right? And then the question says, if the rear wheel are powered, whereas the front wheel are free to roll, determine the maximum number of 150 kilogram crates for the forklift that the forklift can push forward, right? The coefficient of static friction is given there for both for the wheel and also for the crate and the ground, right? So basically, several information is given there. One is in terms of the function of the two tires, front and back, right? It says that the rear wheel, meaning the back wheel, the wheel at the back is powered, meaning that is the wheel that is pushing the forklift front to the front, right? And then the front wheel are free to roll, meaning that that wheel is just following the motion, right? So what this means is you have to understand first where is the friction in this case, right? So the friction is at the rear wheel, right? Because that is the wheel that have to actually push the whole thing forward, so the friction happens there, while the front wheel is just follow the movement and rotation, right? So there's no friction there. That's number one. That will affect your free body diagram. Number two is the number of crates is the thing that we have to determine, and hence the weight of the crates depend on the number of the crates, right? So but the thing here is when we draw the free body diagram after this, we will see that several things that is not given. One is the dimension of the crates, right? So in terms of the exam, when the dimension is not given, said that, so that is the hint already that you do not need to consider for tipping or slipping, right? Because there's no possibility of tipping, right? Because if there's any block that is possible to tip over, the dimension must be given, because you have to consider the moment, right? In this case, there's no dimension given for the crate, hence there's no tipping possible, hence it's just about pushing it against the friction for that block or crate to slip, right? So that's the one information. Number two is the contact point between the crane and the box and the crates, right? It doesn't actually specify where it is. So that's one thing that I think will significantly affect how you draw the free body diagram. And it is based on this assumption, basically, is that the force of the crate, the force of the, meaning the front of the crane that is pushing the crate, is actually at the same point on the ground where the friction is, right? So that is another point that if without this assumption, you cannot actually solve this question, right? Because if the force towards the crate is at the middle of the height or something, then that height needs to be there for you to consider that. And if that is the case, then there's a possibility of tipping or something, so it's actually at the bottom of the crate, right? So that's two information that I think normally for myself I wouldn't put question like this with that kind of missing assumption, or the assumption that the student needs to be able to assume themselves for first year student in this university, normally that is quite unfair, right? So that's why this question normally will not be there in the exam, right? But however, because we already have touched on this, so we'll go straight and try to solve this question, inshallah, for those who are interested, right? So let's go for the free body diagram, right? So now, in terms of the free body diagram, hopefully you have that image with you already or in mind or something. So you have to basically separate the forklift and the crate, right? So basically, if you just consider something like that, right? I think that's fair enough. And then it is pushing, basically I'm not sure how to do this, so it will be pushing some crates there, right? So let's say this is a combination of crates, right? However, number of crates we do not know. That's the question that we have to determine, right? So here, several things. So the point G is already given, the location, right? So the location given, and then point A, point B. So in terms of location, let me draw the location first. So this one 1.05 meter, 0.375, and then this height 0.75 there, right? Even though this height is not needed in terms of the calculation because we don't have moment in that sense, right? Yeah. So basically the gravity is already given, right? So not the gravity, sorry, the weight of the crate and the weight of the crane. What am I saying? The weight of the forklift, right? So this is 12 kilonewton, right? So we have the weight there, and there will be a normal reaction here and here, right? So this will be an A and an B, right? However, friction will only be at the rear tire, right? Because this is where it have to move the thing forward, right? So the friction will be there. In this case, it will be like this, F8. Then this one should be the maximum because the question says what is the maximum number of crate that can be pushed, right? So that requires the maximum power forward, so the maximum friction there, right? So the mu s is already given to be 0.4, so here is 0.4 and A. Hopefully you can see what I write here. So the red one there, the red one here is 0.4 and A, right? So that's the friction there, and of course the question that in mind here is how is this reacting to each other? So in this case, the force is here. So let's say F, or let's say P, right? So this one will be P. It's at the bottom basically, right? That's the only way you can actually solve this one. If it's having any distance upward, then it will have some moment that you have to consider, and that distance is not given in any way or form in the question, right? So the only assumption that we can make is that the force is at the bottom, and the forklift is pushing from the bottom, right? So that's the thing, right? Which I think it's unfair to ask a first semester student in the university to think that way and that far in order to draw the free body diagram. That's just my opinion, right? Okay, so in this case, if we just draw also here, we do not know the weight, and then we have the normal reaction of the crate, it's the weight of the crate, and then we have the friction of the crate, should be the maximum also, and the value is 0.35. This is mu for the crate, and then N C, right? So that's basically the item that you have in terms of free body diagram, right? So how many unknown do we have? So in this case we have NA, that's one, this is still NA, so one unknown, NB, another unknown, P, three unknown in this free body diagram, right? So meaning if you have three equation and three unknown, you can solve, right? So meaning from this free body diagram itself, you should be able to draw, calculate all the three unknown. And then what we need is actually on this side. So if you can calculate what is P, you can calculate what is N from NC here, we can calculate what is NC, then we can calculate what is W, and hence we can relate to how many box or how many crate that it can push, right? So let's solve this one here. So what do we have? So this will involve simultaneous equation, right? So let's say in this case summation of, if we do summation of fx equal to 0, what do we have? If we take to the right as positive, is this is still in the frame, or is it? It's just in the frame, right? Okay. So in this case we have 0.4 and A to the right, nothing here, minus P to 0, right? So basically, and A is P over 0.4 basically, right? That's one. And then if you do summation of, we have enough space here, we do summation of Fy equal to 0, positive upwards. So basically you have NA, and then you have plus NB, and then you have minus 12 to 0, right? Is that all? Right? Okay. So here, is it all? NA, 12, NB. Alright. So from here, you can relate basically, what can you relate? If I plug in here, can I solve for something? Okay, if I plug in here, right? So in this case, it will be P over 0.4, I didn't do my calculator unfortunately, plus NB minus 12, okay, we put it that way first, and then we take summation of moment equal to 0, right? And for moment, because we have here NB and P, if I take moment at point A, then I also have NB and I can solve for NP, right? Alright, so in that case, if I take about A, so if I take counterclockwise as positive, right? So you have NB times the distance is 1.05 plus this one will be 1. What is this? 425, is it? 425, right? And then minus 12 is the distance of 0.375 equal to 0, right? So here you can solve for NB actually. Right, so NB will be basically 60 over 19. Okay, this is what I have calculated earlier. So in that case, if you plug in here, you can calculate for P, which will be 336 over 95, or basically 3.537. Right? Now, because what we need is P, right? So, simultaneous equation, you can do whichever best ways that suits you. I just so happen to just substitute it that way, right? It can be different, because what I done in the paper just now, just now, is different than here, right? But it should give you the same answer anyway, right? Meaning in terms of the substitution. Alright, so then if you have P, then you have already this P here, you can straightway go in this side here, right? So for this free body diagram, if you do summation of Fx equal to 0, then you have P, which is this one, 3.537 minus 0.35 and C equal to 0. So NC, you can calculate what is the answer, and if my calculation is correct, it is basically 10.1 there, kilonewton. And then if you do summation of Fy equal to 0, then you'll have NC, which is 10.1 minus WC equal to 0. WC is basically 10.1 kilonewton. Right. Of course, WC, it seems something like a toilet or something, but that is not related at all, right? Now, but I'm not sure how many of you get that, because in Malaysia we don't have WC equal to toilet, right? But when I was in where is it? Is it in Europe? The symbol WC is for washroom, right? Alright, anyway, so what is the question again? The question is, what is the maximum number of crate that it can push, right? So we already have the information that each one is it 15 kilogram? 150, sorry, 150 kilogram each, right? So in that case, now from this one, WC, so maximum, because this is the maximum weight that it can push, right? Because if the weight of this is much more than this, or a little bit more than this friction cannot, because this is already the maximum friction, it cannot give more friction than that. Hence, the force here cannot be more than that anyway, already, right? So the maximum mass based on this, if you divide by gravity, you will get 1029 and 1029.6 kilogram, right? So the only question left is how many box, if this is the maximum number of mass, right? So for one is 150, right? So if you divide that, you'll get 6.86 box, or basically crate, right? So what is the maximum number? It cannot be 6.8 box or crate, right? It can only be either 6 or 7. So the maximum number is 6 crates, right? Because it cannot go to 7. 7 is already exceeding the maximum, right? It can go only until 6. So the answer will be maximum 6 box or crates, right? So that's how you solve this particular question, right? So what I want to highlight is basically from the beginning, there's this assumption embedded in the question that you have to, because if this one is having some elevation there, because initially when I just look at the diagram, you can relook at the diagram itself, I would assume that, because the crate is something like that, so we consider the force here at the middle, right? But if that is the case, then we have another unknown of the height there, which creates another problem, and you cannot solve the question, right? So that's how that's the only point that I want to highlight here, so that if any other if my student there still cannot solve this, because it is based on this assumption there. Alright, so we will go into the next question after I erase this on the whiteboard, inshallah. Alright, now to the next question. So I'll put it there, the diagram, also the question. So if you read the question, and if you look at the box there, you have two blocks, right? The red one is block A, and the green one is block B, and it is on a slanting surface with an angle theta there, and then you have the cable and the pulley there, right? So the configuration of the pulley there, you can see it means that if block A is to go downwards to the left, right, downwards, meaning the block B will be pulled up by the cable, right? But if the block B is going down, block A will be pulled up, right? So that's how it is being connected there, right? So going to the question, if the coefficient of static friction at contacting surface between block A and B is mu s, and between block B and the bottom is 2 mu s, determine the inclination theta at which the identical blocks, each of weight W, begin to slide. So there's no number here. It will be always in terms of mu s and also W perhaps, right? So that's the question. What is the inclination theta which the block begin to slide. So the question here is, what is the possibility of the impending motion, right? So theoretically there's two possibility, right? One is block A will slide down to the left and block B will pull up to the right. Another one is block B is sliding down and block A will pull up, right? How do we know which one is it, right? Is there any logical way to understand this? If you see the friction between A and B is mu s, but friction B and the ground is 2 mu s. So meaning that the friction down there is much higher. So what does that mean, right? So can we think of something there, right? But however, we have to keep in mind also, because of the cable on the right, if the cable is having tension T, at block A you have tension T to the right, upwards, right? But for block B, you actually have two cable. So meaning there's T and T, meaning 2T to the right, right? So there are several factors there, which means that I'm not sure is there any logical way to say that one will happen or the other case, right? So if you have to assume both, then we have to assume both, right? So let us do that, right? So if we take note of the diagram, and we will try to draw the free body diagram on the whiteboard, and we will try to draw both free body diagram on each side and see how it goes from there. All right. So if you draw the free body diagram, so we'll just draw the two slanting block, right? So something like this and something like this, right? Do we have enough space? I'm not sure, but okay, we'll try for a side. Okay, we'll draw on both sides there, right? So each block will have weight W, right? So that's the same thing, right? So that's the common thing. So W for all. So W, so we have W here with the angle theta. We have W here with the angle theta. So similarly here we have W with the angle theta. So we have W with the angle theta. Right. And then what do we have? We have the normal reaction, right? So how to label this? So if I say my normal reaction here will be NA. Should I label that NA? Okay, we label it as such, and down there we label it NB, even though it doesn't, because it's between A and B, should we label it NAB, but just to make it short, so we label that NA. So this will be also NA, and then this will be NB, right? So in that case, that's the same, right? NA, NA, NB. So that's just normal forces between two objects, right, or two surface, right? So okay, what's the assumption just now between this one? This one, our assumption is A is moving down and B is moving up, right? Can you see that? In this case, we are assuming A is going down, so okay, should I write it further apart? So meaning that A is moving up because B is moving down, right? So that's the opposite. So in this case, block A, if you do not remember what is the original question, you can go back to the image, right? Look at it again. So on this side, we assume block A on the top going down, where block B going up. In this case here, we assume that block B is going down and the block A will go up on top of it, right? So that's the difference, and that will make the friction to be different, right? So in this case, because block A is going down, friction is on this side, right? So and you have mu s, right? So mu s and A. So if this is in this side, so this one will be on the opposite side, right? Mu s and A. Correct? Right. And because this block B is going up, so between it and the surface is also friction going down. So mu s, 2 mu s and B, right? Because the friction is 2 mu s, right? Okay. So that will be the free body diagram of that question there. It's not finished yet because we have the cable there. Okay, might as well draw the cable straight away, right? So if you have this one, this is tension T there. So if we draw the cable, because on this side we have a pulley, right? So so this is tension, this is tension. So this is 2 tension, right? Hence this, in this case, this is 2 tension, or 2T basically, right? Right. So similarly here we have T, we have 2T. Right. So on this part here, block A is going up, meaning that friction is here, right? So mu s and E. So if this is here, this is the opposite way, mu s and A. Correct? And because in this case block B is going down, block B is going down, then the friction is going up. So 2 mu s and B. Right? Because the motion is going up, the motion of this is going down, so the friction is in that direction. This one, the motion is going up, so friction in this direction, right? It's basically the opposite of this one, right? So you can see that the free body diagram is different because of the two scenarios, right? This and this. Okay. So which one do we want to solve first, right? Because then we have to solve and check, right? What is the case, right? So, and the question is actually for asking for theta. So that's the interesting one. So if you do this, okay, this will involve some simultaneous equation, right? So let us, what to do now? So let us do, okay. So in terms of the axis here, I will use in according to the slanting, right? So I will use x and y in that case, x and y, because that seems to be easier because most of the forces is in that inclination, right? Except for the weight. The weight is only one, right? But if I take x and y like this, then all of the forces except for W will have theta, right? So that is more complicated, right? So why do you want to make trouble for yourself? Alright, so I will take this as such. So in that case, if you do summation of F, okay, we are drawing free body diagram of, okay, maybe we have to label, right? This is free body diagram 1, this is 2 in this case. So if I draw a free body diagram for free body diagram 1, so if I do summation of Fy equal to 0, meaning that one is 0, right? So you will have an A minus W cos theta should be equal to 0, right? Right. So because what we want is theta, right? So then we'll get W. Okay. So then NA is basically equal to W cos theta. Right. So if we do a summation of Fx equal to 0, that way, right? So you have mu s and A plus T minus W sine theta equal to 0, right? So NA is this one, right? So it becomes mu s W cos theta minus, okay, plus T minus W sine theta equal to 0. right? Or if you go on this side, so if we were to make it similar, so t equal to, if we bring the rest here, so w sine theta minus mu s w cos theta. Can you see that? Is it okay? That's beyond the limit. So this one is still here, right? Okay. So from here, basically t equal to w sine theta minus mu s w cos theta, right? We are end up with that one, right? So now this is for what we get from free body diagram 1. What about free body diagram 2? So for free body diagram 2, right? So from, in this case, we'll have NB minus NA minus W cos theta equal to 0, right? This one, and this one have Y component there. So, but NA is already here, right? So NB minus W cos theta minus W cos theta equal to 0. So basically NB will be 2W cos theta, right? Minus 2, then we bring that, so it become 2W cos theta. Alhamdulillah. And then if you do summation of fs equal to 0, okay, we are running out of space here. So if you summation of force, okay, this is okay. So I'll continue here, right? Okay. So summation, this one is okay. This one is summation of fy, right? So if you summation of fx equal to 0, so we'll have 2t minus mu sn a minus 2 mu sn b minus 2 mu sn b minus w sin theta minus w sin theta equal to 0. Right, 2t minus mu s and a minus 2 mu s and b minus w sin theta, and t is already equal to here, right? So t equal to the whole thing, so 2t, we plug in this whole thing, so 2 times w sin theta, and then this one minus 2 mu s w cos theta. Right, so 2 times the whole thing, and then minus mu s, so NA is already here, right? W cos theta, so minus 2 mu s, sorry, where am I? I'm here, right? Minus mu s NA, so minus mu s, and A is W cos theta, so W cos theta. And then minus mu s and b, and NB is already here, right? 2, so minus 2 mu s and b is times 2, so times 2 here becomes 4, and then W cos theta, right? So 2 mu s and b, 2 mu s times 2 W cos theta becomes 4 mu s W cos theta, and then here minus W sin theta equal to 0. What do we have here? Right. So that we can take out W, right? So in this case, because all have W, and W, and W. So if we take out W, multiply with the whole thing, so W can cancel out. Right? So basically, we'll have so sin theta is. Okay. In this case, 2W sin theta minus W sin theta becomes sin theta, right? Okay, maybe I should do one by one. So if we cross W, and W, so 2 sin theta minus sin theta becomes sin theta. and then 2 minus 2 mu s cos theta, and then minus mu s cos theta becomes 3. Minus 4 mu s theta becomes 7. Minus 7 mu s cos theta equal to 0. Basically, sin theta equal to how to do this? 7 mu s cos theta. Is it still in the frame? This one still okay. So from here, bring here cos becomes okay. This goes here. So sin theta divided by cos theta becomes tangent theta equal to 7 mu s. So meaning theta is 7 mu s. Right, and we cannot go further than that because we do not have any value for mu s. But it will be arctangent or tangent -1, 7 mu s, right? So whatever that value is. So if mu s is 0.2, then you can calculate that one, right? So it is a certain value, right? So let us try to calculate this one, right? So this is basically the calculation for that one. We have to erase because we do not have enough space for this one, but we'll keep this value. So for here, I'll write it in red. We have calculated that theta is tangent 7 mu s. So that is our final calculation, right? Now, what about this one? Where? Okay. So it is this one. No, should I erase because the calculation is quite similar, right? Except for several, but okay, we will try to do it again, right? So, all right, for this one, so let's use. Okay, we have here x and y. So let's label this 3 and 4. Right, just to use a different number from 1 and 2 here. Right, so in that case, if you do from 4 free body diagram number 3, so you do summation of fy equal to 0. So you have NA minus W cos theta 0, so NA equal to W cos okay, so if hopefully I have enough space. Okay, I'll put it here because is it enough? Okay, summation of fx equal to 0. So basically we have t minus mu s and a minus w sine theta equal to 0. In the frame yet? Okay, we have another line you can do, right? So 3 minus mu s and a minus w sine theta. Right. So if I bring everything there, t equal to mu s and a. So and a is already here. So mu s w cos theta and then plus w sine theta. Right? We are bringing that on the other side there. So it becomes plus and a becomes w cos theta. I'm skipping one step there. Alright, so okay, this one it is already also. So now, for free body diagram number 4 then. So if you do summation of fy equal to 0 for this one, so you'll have nb minus na minus w cos theta equal to 0, right? This one y, and then y. Alright. And a is already here, so you can plug in there, right? So and b, if we bring everything to other side, so na plus w cos theta, or na is w cos theta plus W cos theta. Is this correct? And A is W cos theta. So and this one is W cos theta also. Wait, which block I'm using? Okay, this one is here, right? Because I'm confused already. So NB minus NA minus W cos theta. So that's correct. So NA is also W cos theta. So in this case, NB becomes 2W cos theta. Is this correct? Is this accurate? I've already forgotten one. Okay, summation of fx equal to 0. So you'll have mu x and a there, and then plus 2 mu s and a going up also, and then plus 2t minus w sine theta equal to 0. Okay, so you have 1, 2, 3, 4, right? 1, 2, 3, 4. Okay. So mu s and a is already w cos theta. So mu s and a is w cos theta plus 2 mu s and a. Wait, this one can be added, right? Mu s and a plus 2 mu s and a. Is it? So if I do that first, it becomes 3 mu s and a, right? So 3 mu s and a is w cos theta. I hope I'm doing something correct. And then plus 2t. T is the whole thing. So plus 2 times the whole thing, right? So plus 2 mu s w cos theta, and then plus 2w sine theta. That is from here. And then minus w sine theta. Minus w sine theta equal to 0. Am I missing something? Because this one will be what? Let me check. 2 mu s and e, right? And e is w cos theta. Wait, where is NB? Okay, I did make a mistake here. This is to NB, right? Okay. I am so sorry. Okay. So I also make mistake here. So NB here. So meaning that where is it? So in this case, this is different, right? Okay, let's go. Okay, so this one is, the whole thing is wrong. Okay, so mu s and a becomes, okay, we will do it again. So this one is mu s and a plus mu s and b minus 2, plus 2t minus w sin theta, right? Okay, mu s and a is this one. So mu s w cos theta plus mu s and b. So plus 2 mu s and b is this one, right? 2w cos theta, right? So this plug in here, so we have 2 here. So plus 4 mu s w cos theta. And then plus 2t. T is the whole thing there. So plus 2 mu s w cos theta plus 2w sin theta. And then minus w sin theta equal to 0. Alright, so mu s, okay, here we can already cancel all the w's, right? W, and w. Now, so mu s cos theta, 4 mu s cos theta, and 2 mu s cos theta. So becomes 157. So becomes 7 mu s cos theta plus 2 sin theta minus sin theta. So plus sin theta equal to 0. If we plug in, if we bring here, basically, what do you get there? Sin theta equal to minus 7 mu s cos theta. Or then you bring cos here. Tangent theta equal to minus 7 mu s. So theta equal to tangent, make this 1 minus 1 7 mu s. Right? So that is the answer here for this one. Right? So what does it mean? Because, missing something. We have negative here, right? Minus 7 mu s. Right, so here you have theta equal to tangent negative 1, 7 mu s. Here tangent negative 1, minus 7 mu s. Right, so 1 actually relates to a certain angle, meaning the theta for this one, theta equal to some value there because we have a positive value. But for this one, we actually get a negative value, meaning that it is, for this to happen, for block B is the one sliding and this one is not, the theta have to be totally the opposite, right? Which is not the case. So meaning that from here, this assumption is the correct one because it gives you a positive theta. This one actually gives you a negative theta, right? So it's not a correct one. So that's basically the question. If you have a question like this, so sometimes you have to assume something and then you just have to check in the end, right? So I hope this is helpful for some of you. For some of you this might be nothing new, but for some you might learn something, hopefully, inshallah. Alright, so thank you very much, and we will end the session here. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Wassalamualaikum warahmatullahi wabarakatuh.